Imagine you are standing in a room. In front of you there is a wall. Your goal is simple. Walk towards it. You take your first step, a big one, that covers half the distance between you and the wall. That was easy enough. Now, you stand at the halfway point. For your next step you do the same thing. You cover half of the remaining distance. You are now 3/4 of the way to the wall. You are getting closer, which is exactly what you wanted. The wall feels much nearer now, its texture and color more defined. You can almost feel the cool plaster against your fingertips. You decide to continue this pattern. From your new spot you take another step, covering half of the tiny distance that is left. Then you do it again, and again. Each step you take is smaller than the last, a mere fraction of the previous one. The gap between you and the wall is becoming incredibly small, almost imperceptibly so. You can see every tiny crack and imperfection in the paint. So, let's put a more formal but still friendly name to this idea. In mathematics, a limit is the value that a function or a sequence approaches as the input gets closer and closer to some specific value. Think back to our wall analogy. The function was your rule for walking. Always move half the remaining distance. The input was the number of steps you took. As the number of steps you took got larger and larger, your position got closer and closer to the wall. The wall is the limit as your steps approach infinity. It's a way to talk about infinity in a controlled way. Mathematicians needed a tool for spots without a clear-cut answer. What happens right at the edge? What is the value at the moment of impact? Sometimes you can't just plug in a number and get a neat answer. Limits. Let us peek at those tricky spots by looking at the behavior of numbers all around them. It's like judging someone by consistent patterns over time. Limits don't care if the function reaches the destination. In our wall example, you never touch it. There might be a hole, a gap, or a completely undefined point right where we want to look. Limits sidestep that problem by focusing on the journey. Let's make this even more concrete with a simple numerical sequence. Consider the numbers. 1/2, 3/4, 7/8, 15/16, 31/32, and so on. At first glance it might just look like a list of fractions, but there is a clear pattern here, one that mirrors our walk towards the wall. Each number is getting a little bit bigger than the one before it. 1/2 is 0.5, 3/4 is 0.75, 7/8 is 0.875, 15/16 is 0.9375. The numbers are growing, climbing upwards, but their growth seems to be slowing down. Where are they heading? Each number is getting closer and closer to the number 1. The difference between each term and 1 is getting smaller and smaller. Do you want to be within 1/1,000,000th of 1? No problem, just go far enough along in the sequence and you'll find a fraction that does the job. This is the core idea of a limit in action. This idea of getting infinitely close to something is not new. It has puzzled thinkers for thousands